All right, welcome everyone to this session. My name is Philippe Ozil. I'm a senior developer evangelist at Salesforce, and I'm pleased to welcome you to talk to you about deploying an event-driven software architecture with platform events. Before I do that, I'd like to give you the forward-looking statement. Because we are a publicly traded company, please do not make any purchasing decisions based on what I'm going to say. Only base your purchases based on what is currently available in the product. That being said, here's our agenda for today. I'm first going to talk to you about event-driven architecture from a context that is totally not related to Salesforce, a general concept in terms of software architecture. And then I'll deep dive into what are platform events. That's the way to deploy event-driven architecture within the Salesforce platform and outside of the Salesforce platform. So, event-driven architecture. Event-driven architecture is focused on events, and events are a quick way to exchange data among multiple points. And the concept behind this particular architecture is that it deals with runtime and real-time, communication. So this is not something that has to do with procedural programming in the way you work. This is something that goes in a sort of network. And the important concept behind that is that communication goes one way. Events are a unidirectional concept that works with fire and forget, meaning that there is no callback. An event is being pushed to a recipient. There is no exchange of information like you would have in a traditional request and response model. So the model behind that is called the publisher-subscriber model. And this is something that is shared in the industry for getting a lot of key benefits, such as decoupling. So that means the recipient doesn't know about the subscriber, the publisher, sorry. And that also allows us to scale because we can deliver a lot of messages this way. I'm going to detail a bit more what this publisher-subscriber model is about. We really need to get into this because this is the core concept behind software-driven architecture. In the publisher-subscriber model, everything revolves around an event bus. The event bus is the channel which carries the events or messages. It is split into several channels, so you could see it like pretty much like a form which is organized into several topics. Then there are event consumers. These are different endpoints that are interested in specific kinds of events, and they subscribe to the event bus. By subscribing, they're saying basically, I'm interested into this kind of message, so they're subscribing to a specific channel. Then you have event producer, which publish messages, and the messages can carry some data. Now, what is interesting here is that the event producer does not know about the consumers. Its only purpose is to publish to the event bus. The event bus is in charge of sending the right messages to the right consumers. And what happens in practice is that it's broadcasting to every consumers that have registered to the particular channel. Remember that there is no bidirectional communication. The producer does not know how many receivers, how many subscribers, consumers were listening to this particular message. It doesn't even know if they received it or not. Its sole purpose is to send it to the event bus. So how does that compare with a more traditional architecture? For example, here I've given you an example with traditional request-driven or service-oriented architecture. I've based my example on an e-commerce solution. So you have a shop, a payment module, newsletter module, inventory, customer database, and reporting. All of these modules share multiple dependencies to each other. And that's the typical problem behind this kind of architecture. For example, the customer database has dependencies to shop, payment, newsletter, and reporting. The problem with this kind of architecture is that there is something called tight coupling. Every module depends on the other. So for instance, if we want to deploy a new version of our customer database, there's going to be something called the ripple effect. Because we're going to impact all of the dependencies to this particular service, we're going to affect a lot more services than just the customer database. And in fact, we'll need to update every module that relies on this particular service. So that's the main problem behind this classical architecture. Now compare that with an event-driven architecture. The integration in an event-driven architecture is only point-to-point from the service to the event bus. And that's way simpler in terms of dependencies. There's no dependency or a single dependency. And this is called the separation of concern. So in this particular case, the shop payment and user do not need to know a lot about the customer database. They only are tightly coupled with the event bus and not with the other services. Let's have a look at an example. So here again, we see our different services with the bond with our event bus. And we can see that if we issue an order, there's going to be an event being sent to the event bus, and then the different services which are registered subscribing to this particular event will receive the message. Now, it's important to consider event-driven software architecture with the fact that events are just state change. They are not actions. So you're not requesting for something. You're notifying to your subscribers that something has already happened. Then it's the purpose of your the subscribers need to fetch the information, more detail about what happened. Let's now jump to the Salesforce part. Let's have a look into platform events. Platform events are not new. They were released in summer 17, and they were updated in winter 18. So I'm not going to talk too much about the roadmap, but this is already happening. This is already available. How many in the room have been using already the streaming API? Some of you have been using it? Yes, a few? Great. So you'll see that a lot of similarities. I will detail this a bit more. The concept behind the streaming APIs is very similar to platform events. It relies on a publisher-subscriber model, so this is really common. But there are differences in terms of how we manipulate those APIs. One of the first differences is that, for example, the platform events are more flexible. We have some declarative options to manipulate platform events, while the streaming API is code only. We do have code for platform events, but we're going to see that later. Also, a major difference is the messages, the events that are being sent by platform events are actually typed. So there's strong typing with different sets of type, which are not necessarily supported by streaming API. There are some considerations. I will go more into details on that also later. And lastly, one thing that is common between the streaming API and platform events is the fact that they are not persisted. Events and event-driven architecture is about being real-time, And so we are never persisting data to database. You can, but you have to take the message and store it in database. By default, platform events are never stored in database. What does this mean? This means that we're only keeping track of the messages for 24 hours if we want to replay them, and I will describe these capabilities also in my presentation. But it also means that we cannot query these messages. We cannot write a SOQL query, Salesforce Object Query Language query, to retrieve those objects. There's also no user interface to display those types of events. So you don't have a record tab in which you can show your platform events. This is not something that is provided out of the box. You could build something like that, but it will only work with the events that were already registered. Now, I mentioned that there are a few similarities between platform events and the streaming APIs, and we're going to see that more in details. Now, for those of you who are not familiar with the streaming API, there are two types of events that can come out of the streaming API. First, there are push topics. Push topics are defined by a SOQL query, and they actually track the state change on a particular record. So we're looking at a specific SOQL query, and if the result of this query changes, then we're streaming an event out of it. So the data structure of the push topic is defined by the SOQL query you write to define this particular event. If you're including free fields, and the free fields in your SOQL query will be also the free fields that you'll get for your push topic. Then there's also another type of streaming API event that you can have. It's called generic events. Generic events are triggered manually, but they are unstructured. So basically, you get a 3,000 string character message that you can fill up with any kind of data, but there is no control on the structure of the message. So you can use JSON, you could use XML. It's up to you to set up your structure. There is no validation of the type of this particular message, and you cannot have binary content, for example. Now, back to platform events. The data structure of platform event is based on a structured type. It's pretty similar to creating a custom record with custom fields, except there are some limitations in the type of field that we can support with platform events. Then there's also another difference in terms of publication. We do not publish platform events in the same way we do with streaming API events. For platform events, this is the most flexible part. We have declarative approach with clicks, not code, and we also have full code approaches. For push topic, you don't control when you publish an event. For the push topic, the events are only pushed or published when the result of the SOQL query changes. And then for the streaming API, it's for generic events, sorry. The publication is only triggered by REST API call. So it's a full code solution. And also there are some differences in terms of propagation of the message. For platform event, it is a full broadcast, same thing for push topic, but for generic, there's also an interesting option which allows you to pick a number of recipients manually by specifying I want to send this particular event to these subscribers only and not to the full list of recipients. One last thing, for subscription, platform event again is the most versatile solution. There are a lot of options, code or no code. And for the streaming API, against the full code solution, you have to implement something called the buyer protocol. I will go back to this particular protocol because it's shared also by platform events. But let's now focus solely on platform event. We're not going to talk anymore about the streaming API. I want to talk more about platform events. So here we see our platform event bus. And we're going to have a look at the different publisher options and the different subscriber options. For publisher, there are basically two types. There are publishers which are within the Salesforce platform and publishers which are living outside of the platform. So these could be, for example, on a Heroku application. It could be on a mobile application, on an IoT device, anywhere else. And depending on the type of publisher you're publishing a message with, you have different options. First, let's have a look at external apps and the platform. If you're using any one of these two solutions, you have to use the Salesforce platform APIs to publish events. There are multiple APIs you can use to publish platform events. I will also show some examples about that when I'm going to show some code. You can use the SOAP API, the REST API, or the Bug API if you want to send multiple messages. Now, if you're publishing events within the Salesforce platform, you can use Apex. I'm also going to show code showing how you do that. And you can use some more declarative tools, such as Lightning Process Builder or Visual Workflow. So these are tools that are great for admins because you don't have to code anything. It's just a matter of clicking. Then let's have a look on the other side, on the subscriber side. Same thing, on the subscriber side, you can receive events within the Salesforce platform, or you can also receive events outside the Salesforce platform. And there are also different solutions depending on which type of subscriber you're having. If you're receiving events outside the platform and inside the platform, you can use, again, the buyer protocol. So I will, again, get more details into that. Here I have listed some implementations of this protocol. These are the ones that are compatible, written in JavaScript. Comet, Socket.io, and Faye. These are libraries which allow you to receive platform events inside or outside the platform, the Salesforce platform. If you're inside the Salesforce platform, there's a very simple solution to capture a platform event. You can use an Apex trigger. It's pretty similar to the writing a trigger that acts after a record has been inserted. Something very simple. I'll also show a code example of that. And then the last option, which is new in Winter 18, this particular set has been added in Winter 18. There is now the Lightning Process Builder and the Visual Workflow, which also allow you to declaratively trigger a process or a flow based on a new platform event that is registered. So this is the full spectrum of the different tools we have to publish and subscribe platform events within or outside of the Salesforce platform. I've mentioned several times the buyer protocol, so I want to just talk a bit more about this thing. The buyer protocol is a push protocol, so it's different from HTTP, which is a typical request-response protocol, in the way that the communication is initiated by the server. The server pushes messages to the client. If you compare that to an HTTP exchange, in HTTP, the client does a request to the server, and the server responds with some content. So, for example, when you load a web page, you request a specific URL, you get an HTML file, and then there are several requests and response that are going back and forth. In the buyer protocol, this is very different. That's the server that is pushing data back to the client. And the client can be your browser, but it can also be another server, by the way. Now, what is specific to the buyer protocol? First of all, the format. The buyer protocol works with JSON. So that's a first. And then there are different ways to transport data from the server to the client. There are two main types of transports that the bioprotocol defines. The first one is called the polling transport. The polling transport is here actually to ensure backward compatibility. That's not the most efficient one. And polling basically means that we're doing a continuous polling on the server. So the client is checking periodically for messages on the server. So it's not very efficient because we're doing a lot of requests for nothing. And then there's the other option, the streaming transport, which is the one that is more interesting because it's the most performant one. And the streaming transport is really something that is new. It's been introduced recently with HTML5. And this is the preferred option. So polling means HTTP, request response. That's efficient. But we have also streaming, which is WebSocket, connection initiated by the server. So what is interesting with the bioprotocol is that there is an integrated logic that deals with the quality of service. What that means is that the bioprotocol will first try to establish communication between the two endpoints using the most efficient protocol, that is the streaming transport. If the streaming transport is not available, if WebSockets are not enabled, it will roll back to the polling transport, HTTP in our case. Now let's look into the structure of platform events. Platform events, as I mentioned, are defined pretty much like a custom object. They have one thing that is different from custom object is that they end up with _e suffix for event. And then in terms of fields, it's really similar to custom object fields. They have a _c suffix. But they're limited to a set of basic types. So for example, you cannot have complex types such as pick list. You cannot have currency. You cannot have master details relationship. It's very limited to this particular field types: text, number, checkbox, date, and time. So how do we usually work with platform events? The way we work with platform events is a typical push scenario. So we send a platform event with generally a reference to an object that has changed, and then we process the event. Now, a good practice to deal with platform events is to not transport all the information about our object in the platform event data, in the platform event fields. We generally want to keep platform events very lightweight and only include a reference to the object that has triggered the event. Why is that? Well, this is related to the fact that the types are limited. That's the first thing. And there's also another interesting thing is that you can actually receive the platform event way later than you have resent it. So the best practice is actually to deploy something called a callback mechanism. You only send the ID of the object that triggered the event, and then the client actually queries for the object in the second query to get back the full object that has triggered the change, or specific fields in the object. This is why you need to do that. Basically, when you send the event, let's say at time t, you can receive the event at an interval between 0 and 24 hours later. That's because the platform events support durable messages. We're only keeping track of messages for 24 hours. So if you just copy some information in your platform event, the data can be actually obsolete by the time you receive it. So it's a good practice to query back the object and make sure you have the latest data when you receive the platform event. I mentioned this replay capability, so let's have a look more into detail about how we replay platform events. So when you issue platform events, they have something called a replay ID, and this replay ID is something that goes incrementally in time. So the first message you will send is actually, the first event you will send is actually event number 1, then number 2, etc., etc. This particular ID is actually bound to the channel, the message type, and it goes on increasing. Now, as I mentioned, we have a 24 hours retention window. So what happens is that we only keep track of the messages that are issued in the last 24 hours. The other message, like message 1 here in this slide here, are actually deleted and they're lost forever. And what is interesting with this retention window is that you can request messages that were issued in the past. So for example, you can, when you connect to the Salesforce platform, you can say, I want all messages starting from message 3. And you could get message 3 and message 4. Or you can also say, I want all messages that are available in my replay window, and you can issue out a new connection with a replay ID of -2. And in this particular case, you would get all the messages that were sent in the last 24 hours. That's interesting in the way that if, for example, your network drops or if you're going under a service maintenance, you will not lose information. You'll be able to replay what has happened in the past. And you get them also in the right order also, which is important. Now, I've been talking a lot. It's, I think, time to have a look at some code. So we're going to study a few examples. Here, this is the code that helps us to publish a platform event. If you are familiar with Apex, you'll see that this is very similar to creating a custom object. Here, we're defining an event called myEvent__e. And this particular event has one field, which is called myEventAttribute. And instead of doing a database.insert, we're actually calling this particular method, which is really the difference compared to object creation. We're using an abstract method called, an abstract class, called eventBus, and we're using the publish method. So this particular abstract class is the way to publish messages in Apex. It works with a single event, but it also supports a list of events. And then the rest of the code is really standard Apex. You'll notice that you get out a database.saveResult object when you're publishing. And this is actually something that is a bit, I would say, the name is not so user-friendly because you're not saving to this database. In fact, you're actually publishing to the bus. Remember that getting this save.database result with a value of success doesn't mean that you actually have, that your recipient subscribers have received the message. It means that your message was sent to the bus. The bus will take care of delivering it to the subscribers, but this can happen way later. Then let's have a look on the other side at subscribing to events. Here, this is a really standard trigger. You could write the same trigger for the creation of a new object. The only limitation for platform events, of course, is that it only supports after insert. You don't have an update for a platform event. So this is really typical code you would find for a new object. For REST publication of events, same thing. We're really having the same API call than for creating a custom object. You'll notice, however, that our event is actually stored under the S-object resource. So it's not an S-object, but it is stored under S-object. That's the little thing that can be confusing at first. But other than that, it's the same kind of an operation. We only support post. Remember that you cannot query for platform events. So post is the only HTTP verb that is supported in this particular case. Now let's have a look at some more complex code. I mentioned that you can also use receive platform events outside of the Salesforce platform. And one of the ways to do that is to use libraries that implement the bio protocol. One of these libraries is called Comet. This is the one that we recommend, but there are other implementations of this protocol. And we're going to study here the code of a Comet subscription. The first thing I need to do when you use Comet is actually to configure this library. You'll need to specify the endpoint that will allow us to receive events. So here, the endpoint is basically your instance URL with /cometd and the version number for the Salesforce APIs. Then another thing that is interesting is that you need to pass the OAuth authentication. Messages, platform events are actually authenticated, so they're not anonymous. You have to obtain the session ID. In our case here, this is actually in Lightning, so we're getting the session ID which was passed as one of the attributes of our component. It's your job to retrieve the session ID of a currently connected user to authenticate with the platform event. Then there's an interesting line here that I've added that's actually optional. Here, I'm disabling WebSockets. Why am I doing that? For the moment, the Salesforce platform does not support WebSocket because we haven't been able to properly secure the WebSocket protocol. So it's something that is in progress. I don't have any deadline release dates to announce. But for the moment, we do not support WebSockets. So what will happen is, if we don't have this particular line, the Comet client will first try to establish a WebSocket connection to the Salesforce platform. This will fail, and it will roll back to HTTP long polling. So this particular line helps you win a couple of seconds by not even trying WebSocket, directly jumping to the HTTP long polling. This is optional. Both with or without the code will work. It's just that you gain a few seconds by not having it. Once we will have secured the WebSocket protocol, we'll be able to enable it and roll it back. Then, once we have established the connection, we're going to use our configuration to do something called a handshake. So we're going to authenticate with the platform. We're going to check if this authentication is successful. This could go wrong if, for example, the OAuth token we get is invalid. And once the authentication is successful, we're going to be able to subscribe to one or more platform events. Now, notice that platform events are actually stored in channel with /event / the name of your event. You can register one-to-one or multiple platform events. And what you define here after that is a callback function that is called each time a message is received on that particular channel. And after that, you can process the message the way you want. You can access the platform event attributes. Here, I'm just showing them in the developer console, and I'm actually putting that as JSON. So this is the full code to deploy as Comet D subscriber. Let's now have a look at some sample use cases. What are these platform events great for? Well, the first thing is actually you can build something called microservices. Remember at the beginning of the presentation I mentioned how when you have a lot of services in your architecture, these services tend to be coupled. With microservices, you tend to build smaller services which are not coupled, and they rely on platform event or a messaging bus to decouple and have a separation of concern. So that's a great use case for these platform events. And then another great use case are integrations. If you have a lot of different platforms that you need to integrate, a message bus is really good for you because it allows us, again, to have the separation of concern and reduce the risk of coupling things. So for example, if you have a Heroku application and the Salesforce platform, if you have a mobile application and another app, you can use platform events to communicate between all of these platforms. And this is particularly interesting, especially if you're doing IoT or mobile, because platform events are happening in real time. So this is very good for you if you need accurate data and real-time data. Another use case that was suggested to me recently is that you can use platform event to actually distribute your processing power. You're well aware that the Apex APIs have their limits, governor limits. We all know that. And so a good way to bypass this limit is to actually do intense processing outside of the Salesforce platform. And using platform event can allow you to offload some of this processing to an external platform. You would send a platform event that signals the start of your processing, do the processing on another platform, and once you get the result of your processing, fire back another platform event back to the Salesforce platform so that you can resume your activity. This is true, for example, for image processing, for video processing, or other complex tasks. Now let's have a look at a practical demo. I'm going to show you how we use platform events in a demo scenario. So I'm going to open an org here. It's actually called the Northern Trail Outfitters. If you've been here at Trailhead DX, we've showcased this particular example. This is a fictitious outdoor clothing company that sells clothing items. So they sell, for example, jackets, backpacks, things like that. And this company actually bundles these items to send them to their manufacturers by using something called merchandise mix. So I'm going to create a new mix called sample. And I'm going to add a few items to this mix. So I'm going to take a backpack, a jacket, whatever. And the idea here is that once this mix is ready, we're going to send this mix to the manufacturing division so that they can check if they're able to produce this bundle of merchandise. Now, the thing is, the manufacturing division of our company, Northern Trail Outfitters, is not using the Salesforce platform. They actually have a manufacturing app on Heroku. Which reminds me that I need to start this particular app, which is not running right now, before I do that. So I'm going to run this app on my computer. It could be on a Heroku server, but I'm actually running it on my local machine. And I'm going to show you that side by side with my app. So here, this is the website that lives on Heroku, on my local machine in this case. And this particular site is in charge of the manufacturing division. Now, when I want to submit my Americanized mix to the manufacturing division, I can do that in Salesforce platform, and this will fire a platform event, and you can see in real time that the manufacturing division received the Americanized mix. Here we use the best practice, so we use the callback mechanism. The platform event only contains the ID of Americanized mix. What the other application, the manufacturing application, does is that it fetches back the information that is associated to this particular reference to the platform, to the Americanized mix. So here we can see our items there. Once the manufacturing division reviews the bundle, they can approve it, and this will fire back an event to the Salesforce platform, and you can see that the status of our mix in the path component here on top was updated in real time. So what I've shown you is a platform event being sent from the Salesforce platform to an external application, and an external application pushing back this platform event. How is that done? So for the Salesforce application, we have issued the platform event using a process builder. So I'm going to show you that really quickly. Here we go. What we did here was a simple process that actually triggers, but is actually watching for a Americanized mix. And if it detects a change of status of a Americanized mix, if the status moved to submit it to manufacturing, then it will publish a platform event with the Americanized mix identifier. So this is how we publish the platform event to the Heroku application. And then the Heroku application uses the REST API to publish the platform event to send it back to the Salesforce platform. So you've seen how we can use platform events to integrate different platforms. It's time for me to conclude. So today I've explained what is an event-driven architecture. I gave you a few tips about how this is, I would say, an improvement compared to a traditional request-driven or service-oriented architecture. I've given you key differentiators such as decoupling and scalability. I've also mentioned, I've also talked about platform events. I've given you the list of possible options for subscribing and publishing platform events. And I've given you some example use cases of those. Now, you can try it yourself. There are two straight-ahead projects, actually one project and a module that I'd like to recommend to you. The first one is the Platform Events Basic. That's a module. It deals with the whole theory of event-driven architecture. And the second one is a project which is really hands-on. It's a very short project. It only takes 1 hour. And it explains how you can build an instant notification app on the platform. And actually, I built this one. In this one, what you can do actually is use a Lightning application that will allow you to have instant notifications about bears sightings in the area. And this code shows you how you can write the Comet code I just showed you in the slides. So it's very practical, it's very short. I really suggest you give it a try. With that, I'd like to thank you, and I will take questions. One thing to know, for the questions, you'll need to step up to the microphone because we're recording this session. Thank you. Yes.
Just to set some context, if we have some notifications on private objects on Salesforce,
yeah,
and we don't want, say, our reps to know, if he doesn't have access to that account, I don't want to send him that, but somebody else that notification. How would I go about it using this?
All right. So this is a good question because the thing is, platform events do not have permissions attached to it. Because they go outside of the Salesforce platform, we don't have any context to whom we're sending the message. So you'll have to implement your own security mechanism in your receivers, in the code of your receivers to deal with that. If you're doing the mechanism with the callback, you would not be able to query from the object. You would just have the ID of a particular object which triggered the event. So you can do it this way.
A couple of questions. Does this new event-driven mechanism, does it support guaranteed delivery? Because I think the previous streaming API, based on my understanding, had some issues with guaranteed delivery.
Sorry, I didn't get it.
Like, if you send a message, is it guaranteed to be delivered? Right? Streaming API.
Yes, well, it is guaranteed to be delivered within 24 hours. If you're online. If you're not online, well, the message could be sent, but there could be no receivers.
Okay. And is this based on JMS underneath, or is
No,
it?
JMS is for Java Messaging Server, so this is not using Java. There are actually two infrastructures that we support here. I would say the basic version is using actually still our metadata database. But then there's a second option which requires an additional license for large volumes, for millions of messages, and this is based on Kafka.
Okay. So if you send a message, it will be delivered at some point in 24 hours, is what you're saying?
Yes.
Okay. Thank you.
Yes.
Okay, so maybe picking up on that last point, if we have a Kafka infrastructure, how could we best consume Kafka events on the Salesforce platform?
You will have to use the APIs, in fact. It's not directly connected to your Kafka instance. It's Kafka in our data center.
Right, so just use the API.
You use one of the receivers we described.
Okay.
When will large volumes be supported?
What?
Large volumes, when they are going to be
Yes.
supported?
So large volume, this is a separate license. Yeah, sorry, I didn't get it.
Already supported?
Yes, it is
Yes.
supported, yes. So what you can do right now is get a developer edition, you get access to the normal volume, but then if you request the large data volume, you have to talk to your salesperson to get a special license to get activated.
Is there any ETA for the WebSockets integration?
Not that I know. Not able to comment on that.
Thanks.
Sorry.
Hi. If we have to create the platform event from a third-party system into Salesforce, can it be done by JWT, or it has to be OAuth?
So right now, you'll have to explore the Comet D options. I have only done it with OAuth,
OAuth, okay.
but maybe it's possible with other option. I haven't tried. It's a matter of calling the library that you're using. So I haven't checked all of the options. Again, Comet D is not the only option. There are other implementation of the bio protocol. Comet D is the reference library, so that's probably where you should start looking because it has the most options. There are other, I would say, secondary implementations like Fay or Socket.io, which have limited options.
Okay. We have a situation where we are not able to make SOAP API calls as of now into a third-party system. So we wanted to see, the third-party system cannot subscribe on our platform event just yet. So we wanted to see if we could publish and subscribe within our trigger itself.
Yes.
Like Salesforce could publish and
So
Salesforce could.
that's a very good point. What you can do is you can write an Apex trigger which will call a web service. So that's a way to convert a bit the platform event to send it in another form outside of the platform. Yes, you can do that.
Okay. And does that help a lot in the CPU time limits that usually people hit during triggers?
So we have different limits in this particular case. There are, of course, the Apex limit if you're publishing with the Apex trigger. But there's also another thing to consider. We have a limit in terms of messages that are being published daily.
Okay.
I don't have the precise figures, so I'm sorry, I don't know it, but it's written in the documentation.
Okay. Thank you.
Yeah, welcome. Any other questions? All right, thank you very much.